All right, hello everybody and welcome to LinuxFest Northwest 2022. This session is called Gaming with Robots, a tool for learning for all ages and skill levels. And it is put on by Sam. Please
Hello.
be aware that the audio and video are being recorded. I have posted a link to the code of conduct in the chat at the very top, and I will now hand it over to Sam.
Hi, thank you so much. Really appreciate that, Daniel.
Mm-hmm.
So thank you everyone for coming to my talk. I want to be clear from the start, this is not a lecture. So if you have questions or want to interrupt, please post your questions in the chat and Daniel will get my attention with your questions. I'll be happy to answer them or to go back over something if I move a little quickly. So feel free to make this interactive. So let's get started with my talk about gaming with robots, a learning tool for all ages and skill levels. First, a little bit of an introduction about myself. I am not a hardware or software engineer, but I am a chemist and a researcher and educator. So I do have an interest in pedagogy and learning and teaching tools, which is part of the reason I'm really excited about this. However, I am an amateur with interests in electronics, code, and embedded systems. And I say this not to be humble or to dissemble, but to highlight the fact that you don't necessarily need to have a formal education to get involved in these kinds of things. So you don't have to be intimidated by people like, oh, I don't have a degree in software engineering and I'm a little bit afraid to get into robotics or something. I'm like, don't worry about it. If I can do it, anyone can do it. So what I'm going to do today in this talk is take you through my experience using this tool as a learning tool for myself and how this project itself could be used by others, or at least as an example for others to find their own tools for learning. So why this project? Well, a little backstory on this. My friends and I, we enjoy doing board game nights, at least pre-pandemic when we still do them in person. We did enjoy that a lot. And one of the games we enjoyed playing was RoboRally, which is a game about navigating little plastic robot pieces around a game board. And as you do, after you've had a few beers playing games, you start to wonder, hey, what if we used actual robots instead of little toy pieces? Wouldn't that be so much cooler? And of course, everything is way more feasible when you've been drinking a bit. And so this idea really stuck with me. And I thought this would be the perfect excuse for a project that I've been looking forward to get myself sort of into learning robotics and more about technology and code. So that's how this project, RoboRuckus, was born. So as a general design principle, there are two parts I want to discuss. There are the game controller, which is sort of the brains behind the thing that runs all the game code and the game logic and simulates the board game. And then there are the robot game pieces. And what these are would be the actual robots themselves that would move around the board like you would move the game pieces in the board game around. Only instead of being little plastic pieces, they'd be robots. So for the robots, when we were talking about this, I was sort of mapping this out. Our first thought was, well, we want it to be an open-ended design so that we could have a lot of flexibility with it. And we want it to be accessible and available. And the obvious choice at that time when we started this project around 2015 was to go with the Arduino platform, where Arduino was a very popular platform there, a lot of good community support, and it seemed like it was easy enough to get into. The game controller itself, we decided to use web technologies to run that. And the reason for this was because web technologies are generally platform agnostic. It doesn't matter whether you're running Linux or Windows or Mac OS. If you have a web browser, you can access, interact with web technologies. They're fairly easy to deploy. Again, you can deploy them to any kind of server, whether, as long as it has a web server, you can run it on there. And they have really good interface design options. So you already have CSS and HTML and all these other interface frameworks that make designing interfaces for these things really very simple. So this was sort of our basic roadmap that we were going with this project. But most importantly, we wanted everything to be as inexpensive and simple as possible because this was not a professional project. We weren't looking to do this as part of a small business or anything like that. This was just a little personal hobby. And so we wanted to make sure that it was cheap and that as we were amateurs, that it was something that we could get into without getting overwhelmed. So let me talk about that game controller for a little bit. I eventually settled on using ASP.NET as the code framework for running the game server. And the reason I chose that was because I had a little bit of familiarity with C# from some previous projects. It had recently been open sourced. So at that time, Microsoft had started open sourcing the .NET framework, which was excellent because I really wanted this to be an open source project and make it really collaborative. There are lots of useful tools in C#, including link and asynchronicity. And very importantly, it was cross-platform at that time thanks to the open sourcing. So now we have things like Visual Studio Code for Linux and Mac OS. You can run and develop and build this entire program on Linux or on Windows or on Mac OS. So there's no real worry about, you can use the same tool chain on any of those platforms. You have to worry about someone saying, oh, you need to download this IDE if you're on Windows, or this IDE on Mac OS, or this IDE on Linux. No, you can use the same Visual Studio Code for all the platforms and not have to worry about having to worry about the tool chain setup. For the actual hardware to run the server, we were looking at using a Raspberry Pi. At the time, they were inexpensive and portable, and they were open source and Linux based. So again, these were things that were important to us. They're maybe not so accessible as they used to be, Raspberry Pis, but hopefully that will change in the near future. But still, the nice thing about this program is that since it is portable, you can run on a Raspberry Pi or any other computer. It's not strictly limited to Raspberry Pis. And the Raspberry Pi also provided a really nice thing in that it was has a lot of good community support. So there's a lot of good tutorials out there for doing the kinds of things you want to do. If you want to set up a web server on a Raspberry Pi, there are lots of really great support out there for how to do that and instructions. And lastly, the Raspberry Pi could be used as a Wi-Fi access point, which means that it could be a single portable box that ran all of the server code. Everything could be done with the single Raspberry Pi. No need to worry about setting up a Wi-Fi router or access point, dealing with port forwarding or networking. It was just one simple integrated box. So this isn't a technical talk, but I do want to just briefly mention a little bit of the design paradigms we use for the server code. So the server code we wanted to be modular, and as you can see, we sort of broke it up into these various modules that were important to us, because again, when you're starting out, you might not know exactly what code you want to write, but you do know what you want your program to accomplish. And so we knew we wanted to have a movement calculator that would calculate the movement of the robots. As they were given instructions by the players, how would those instructions be translated to movement on the game board? And how would the game resolve movement where like a robot wanted to push another robot, was driving into a wall, and how those things all get resolved. And we wanted to have the interface for the users be there, and that user interface would communicate with the game through a SignalR hub. And SignalR is a real-time communication platform that ASP.NET offers, which was another real good bonus to using it. And as you can see, we just have a whole bunch of different modules. In the center there, we have the game controller module, which had all the players and the robots and the whole game state controlled in one place. And so one real nice thing about this sort of modular design is later, as we kept on iterating, we learned we wanted to add some new modules. So some of the modules we added was, for instance, a robot tuner. And this was a interface that allowed us to tune the movement of the robots. And this was because that no two robots off the assembly line, no two pieces of hardware, no two motors off the assembly line will be exactly the same. So to get our robot movement to be more reliable and more consistent, you need to be able to tune each robot individually to its specific manufacturing characteristics. And so having that as part of the user interface meant that you wouldn't have to reflash the firmware on the robots every time you wanted to tune their movement. And so bolting that on to this program was really easy because we were thinking modularly like this. So now I just want to give a few code examples to show how I use this as a learning tool. So for instance, the game boards, they're encoded in JSON, and this is something I had never used before. And this program and this project gave me an excuse to learn how to do JSON formatting, how to interpret and pass JSON instructions back and forth between a back end and a front end, and how to parse it. I learned about link, which was a very good tool in C# that allows you to treat collections and query collections like a database, so you can construct these really sort of intricate queries that let you sort and select certain elements from a collection, like a list or a dictionary, which is very useful for finding specific robots that had certain conditions that were met, like if they were on a certain game board or if they had a certain amount of damage. Another thing I learned about was dependency injection, which was sort of a little tool that we just used, I ran into when trying to run things in instance or static modes. And then lastly, for the robot movement, I had to learn about recursion. And so the reason I'm bringing this up is not because I think these specific topics are important for everyone to learn, but to highlight that when I started this project, I had no intention of learning these programming tools. Like I didn't set out thinking, I want to learn JSON, I want to learn recursion, I want to learn dependency injection, but I knew what I wanted to build this game, and I learned that the tools I needed to use to accomplish that were these tools. So by having a project in mind from the beginning, it acted as a scaffold that directed my learning to the tools best suited to make my project work. And I think this is really an important part I want to dwell on a bit, because when you're first learning programming, you're learning something like a for loop. You'll read in a textbook, okay, this is how a for loop works, and maybe write a little bit of code that lets you have a for loop that counts to 10 or 50 or whatever. And that's great. It teaches you how a for loop works, but you don't necessarily understand why a for loop. Like, why would you use a for loop? You get the how of a for loop, but not the why of a for loop, which sounds kind of like a Zen meditation, the why of for loops. But having context, I think, is very important. And I knew that, I want the robots to move. When a robot encounters another robot while it's moving, like another robot's in the way, that other robot then also has to move. So having that be a recursive function where each robot moves until there's nothing in the way of it, and then the movement continues, was a very natural fit. And understanding that context of, this is how it works out in the physical reality of the program I'm trying to make, gave me an understanding of recursion that I don't think I would have had if I just read it in a textbook or did some exercises from some homework or something. So I think having that concrete context really helps you learn things, and having a project that you know what you want to do helps direct your learning to things you might not encounter otherwise. So just a brief thing I want to talk about here, just some examples of what the user interface looks like. Again, I'm not going to go into too much detail here, but just to sort of show you what we're working with. So this is an example of the player user interface, where they can pick their cards and pick the moves for the robots. So you have move rights, or U-turns, or move forward 1, and there are all kinds of movements they can pick. And again, you can see this is a very rudimentary interface. It's not very pretty, but it is functional. This is an overview of how the game board looks from a game master perspective. So you can see, like, this is the game server, and this is its conception of what the game looks like. You can see that little yellow square is where a robot should be on the physical game board. And so if this is matched in reality, there would be a physical robot in that place. And you can use this to check to make sure, did the robot move to the right place, or did it wander off course? And then lastly, you can see here are some of the parameters you can tune for a robot. Their wheel speeds and other sensor settings. And this is why you might want to have this, because, again, every piece of hardware is going to be a little bit different. There are manufacturing tolerances, so you need to have this to really dial in the settings for each robot individually. So now I want to talk a little about the robots. And I'm going to talk about sort of the phase 1, the alpha version of the robots. And this is from my first experience with these robots. And so when we started out, we made custom robots, so all from sort of scratch, putting pieces together after buying off-the-shelf components. And the reason for this was, first off, kits were not as available and were much more expensive when we started this project. So back in 2015, it was hard to find good robot kits that either were the right size, that were flexible enough to do what we wanted to do, that fit into the parameters we wanted to use. I also thought, again, this would be a great learning experience. I wanted to learn more about robotics, so what better way to do it than to set myself a task, a goal of designing a robot that fit the parameters for this game that we already had a conception of. And this gave me some focus. It wasn't just build a robot, which is such an open-ended question, you don't even know where to begin, but it said, hey, build a robot that's 4 inches, no more than 4 inches on a side, and that has these sort of parameters for navigation and communication. And so that led me to designing a robot like this, where we started out with using navigation. How are we going to get the robots to move? The first thing we thought about was line following. So optical line following is very popular, but the problem was our game board was printed on a vinyl mat, and you'll see some pictures of it later, but the optical line following wouldn't work because there's a lot of color and there's a lot of busyness on the art of the mat, and the optical line following would just get confused by all the other art that was already on the game board. So we decided to try to use magnetic line following, where we'd have strips of magnetic tape underlining our game board that the robots would follow as if they were doing optical line following. So to that end, we started with an Arduino Pro Mini and a Hall effect sensor to try to use that to sense the magnetic field like you would use with a light sensor and in an optical line following situation. We eventually found that the Hall effect sensors weren't sensitive enough and that the Arduino Pro Mini didn't have quite as much processing power as we needed, so we decided to switch to using a Teensy LC, which is another Arduino compatible microcontroller with a little bit more oomph to it, and a digital compass to use as a navigation. And this digital compass had the bonus, not only was it a compass, which was much more sensitive to magnetic fields than the Hall effect sensor, but it also came with a gyroscope built into it. So we got sort of a 2-for-1 deal there. And to communicate with the game server, the robots would use a ESP8266 Wi-Fi module. And these are very popular Wi-Fi modules. They're everywhere. They're cheap. They're a few bucks. And this is a really easy way to get our robots to talk to our game server. So with that in mind, this is, again, a very sort of brief overview of how the robots would work and their code layout is. So if a block diagram of their code layout. So the robots would go into various different modes. They would start up. They would try to communicate to the server. They would inform the server of their parameters and let the server know it's there and check in. And then the robots would just wait. And so the point here is that the robots are stateless. The robots themselves don't know anything about the game. They don't know how many players are in the game. They don't know what space they're on. They don't know anything that's going on. They're just waiting for instructions that are like, hey, move forward. Hey, turn left. And this is really great because it means the robots can be very... there's a lot of open-endedness to the robot design. They can be any design you want as long as they can wait for commands. There's no need for them to have any back-and-forth communication, so it makes the robots very simple to design and makes them really open-ended. For movement, initially, as I said, we use linear movement with a magnetometer to sort of follow the magnetic line, and we also have the gyroscope there to help if the magnetometer drifted off too much or the robot sort of hit a bump or something and got off course. The gyroscope could help direct it back towards the magnetic line to where the magnetometer could take over again. And to turn, we just made 90-degree turns using the gyroscope only. So let's see how the prototype assembly went. So first things first, this is me assembling our first prototype using a proto board and a lot of soldering. And then you can see the first assembled robot, and you can see a little video of it trying to drive. This is always a very exciting moment, a proud parent moment of giving birth to your first robot, and it's driving along, doing a pretty good job, and then it kind of veers off, heading towards the wall, and eventually it crashes into the wall. But hey, first time, pretty good. The only downside to this design was that assembling this robot took hours of soldering, and it was a real pain in the butt to have to cut and trim and line all these wires up and solder them all in place. And you bridge connections, you have to go back and fix things and troubleshoot a lot. So the next task I wanted to tackle was trying to make this assembly process for making a lot more robots. We wanted at least 6 or 7 robots in this game to make this process a lot easier. And that involved doing custom PCB design. So again, this was something I had not even contemplated doing at the start of this project. But by following this project through and trying to meet the goals of the project, I naturally found new skills that I would learn throughout this process. And so with a PCB design like this, you can order them from sites like OSH Park or other PCB manufacturers. It turned out to be really quite easy to make a PCB. Now, this isn't the best design PCB. I'm sure anyone out there who has more experience would be like, oh yeah, you want to change all of this. But it worked, and it was a really great experience that taught me not to be afraid of trying to build a PCB if necessary. So I was going to show you some of our assembly of the robots. So some friends and I got together, got some drinks, and started putting together a little assembly line of robots. One of the great things about this was that a lot of my friends, this is some of their first soldering experience for them. And it was really great to see them who were invested in this project, who really enjoyed board games and hadn't really done this before, but hey, this was a great sort of excuse for them to get into these projects and start developing these skills. And eventually we produced a whole little stable of cool little robots. Now they're kind of janky and they're held together mostly with hot glue and prayers, but it's a start. So again, when we had those assembled, we started thinking about ways to refine and improve. And the next step was to think about, hey, we did this all with hot glue. What about implementing a 3D printed chassis? And so some friends and I got together and we started working with 3D printing design software to model a new chassis. And again, taught us these new skills that we wouldn't have thought about before, like using 3D printing, which again, was not something I'd even contemplated using at the beginning of this project. And so you can see what the new robot would look like with the 3D printed chassis. Yes, it's a box. It's not particularly pretty, but it's very effective and it's way more easy to assemble than our hot glue version. This also gave us the opportunity of implementing a new power system using lithium polymer batteries. Now, lithium polymer batteries was something I didn't know much about at that point, and I mostly use off-the-shelf boost circuits, but even when using off-the-shelf boost circuits to generate the battery charging and stuff like that, I still had to learn about things like current limiting. So I know the robots would draw a certain amount of power. I had to make sure that the battery could supply that power and the booster could supply that power. So there's a lot of sort of learning that went into even that simple upgrade of adding a new kind of battery to the system. So that was the initial robot design. And now I just want to go over quickly how our game board works. I've talked a little bit about it, and I want to show you what it looked like. So as you can see from this, the board will be laid out with these magnetic tape lines on the back of it. And then the robot, in this video, you can see it navigating by following the magnetic tape. And as you can see it moving, you'll see that it wobbles back and forth a bit. And as it's wobbling back and forth, that's the magnetic compass, the magnetic magnetometer, trying to keep itself on that magnetic field line. And it does a pretty good job for a first attempt. And so once we had our prototype assembled, we decided to make a much sturdier board out of MDF. And we put those little magnets, little neodymium magnets, at the center of every square. You can see how that lines up with our printed mat. We want that neodymium magnet in the center of every square to provide a big old spike of magnetic field so the robot could count that as spaces. So you can see, like, oh, if I moved X number of spaces by counting the spikes in the magnetic field, that it count as it moves. And so then we would fill in those grooves we'd cut with magnetic tape. And you can see what a fully assembled board would look like. And this is sort of what it looks like all together when it would be out at an event we took it to. So putting all of it together for our first version, you can see that we have the robots, we have the game board, and up in the top of the corner here, right here, you can see the Raspberry Pi, and that's running all of the game code and coordinating to all of the robots and acting as a Wi-Fi access point for them. So it's really a very portable system where you can just throw that into a bag and take your robots with you and you're good to go. And we use little tablets here to run the user interface, so you can see them interacting with the game board there. So that was where things were sort of left off, 2018-ish, 2019, when we had Maker Faire here sort of shut down in New York, and the pandemic hit, and things were sort of put on hold for a while. A few years later, I started working with the TAG Northwest group here, or the TAG Northern Washington, the Technology Alliance group, and to resurrect this project and sort of take it to a new level. And one of the best things that has come across in the last few years are new robot hardware up. So now kits are more widely available and they're inexpensive. You can see here 4 examples of robot kits that we have been sort of playing with. And one of the best things about them is they're better supported. So you can find a lot of really great online support for these things, and they're also modular, which means that you can use the same pieces for multiple robots. So for instance, a lot of these robots use this microbit, this PBC microbit microcontroller that slots into them. And so 3 of these robots here all use the same microcontroller. So that means that you can take this one microcontroller and take it from robot to robot, which means you don't have to learn whole new skill sets to try to bring new robots into the game. So we purchased a few of these kits, and these are some photos of us assembling them and putting them together. And when we put them down to drive, they seem to work pretty well. And so one thing I want you to notice is that both these robots are moving, but the one on the bottom, the McQueen, is doing a different kind of turn than the one at the top. Where the one at the top can just pivot because it's smaller, the one at the bottom has to sort of like 2-point turn there. And that just shows that it doesn't really matter how the robots move as long as they can accomplish their moves. And there's a lot of room for creativity in how that works. So specifically, these robots are very modular. They're modular in terms of their code and design. So we can use a microbit, which is that robot I showed you, and you can program microbits in MakeCode, which is a block-level visual programming language. You can use MicroPython, which is another sort of popular, easy-to-use language. We've also experimented using a new type of microcontroller called the M-Bits, which has the same form factor as a microbit, but it uses an ESP32 microcontroller with Wi-Fi built in. Don't have to worry about what that really is, but the important thing is it gives you new languages. You can program those in C# if you want. You can do all the back end and front end and robot code all in C# if you want to for a unified coding environment. But you can also program those in Arduino. So people who are familiar with Arduino can use Arduino to come over and feel comfortable with those. And you can see that even with different robot designs, you can have different coding languages and different microcontrollers. You kind of mix and match and get the right language that you want to use with the right platform that you're comfortable with. So it's a really sort of a smorgasbord of options. And it isn't just limited to the code, but also the movement options. So the robots you've seen so far all use wheels to drive. And that's fine. I like that. Wheels are cool. But you don't have to use wheels. People can build walking robots or treaded robots or robots with omni wheels that slide around the game board, or even micro drones that lift up and land. Like, it doesn't matter how the robots move. They just have to be able to do the movement that you give them. If they want to drive forward, how it drives forward is really up to you. The same thing with navigation. So we talked about using magnetic line following initially, but you can use LiDAR or GPS or infrared rangefinders or ultrasonic rangefinder, whatever you want to use. You can really find the movement technology that is most interesting to you and try to implement it. And the same thing with communication protocols. we use Wi-Fi right now to communicate between the game server and the robots, but you could use Bluetooth or long-range radios or whatever you want. So if there's a communication protocol you want to try, the game server doesn't care how the robot talks to it. It just needs to be able to tell the robot to speak the API, and the robot has to respond. And it goes beyond just the robots even. There's a lot of modularity and design options you can do with the board. So this, for instance, is an example of a board we were experimenting with of using a projector to project a picture of the board onto a surface. So instead of using a vinyl mat that we print and lay out, you can use a projected board, which gives you a lot of flexibility to change the board on the fly and scale it up and scale it down as needed. So there's a lot of ways to be creatively involved in this. So now I just want to show you a video of how these robots are being put together and how this sort of works. So first things first, whenever you buy a new robot, the most important thing is to show it off to your friends. That's like the best part of getting your new toys, is showing it off. And that's an example of unboxing with the robots there. And then once you have a robot assembled or out of the box, you want to start testing it and putting it together. And this is a very tense moment in any robot's life, the moment where you're first trying to get it to move. You're like, did I put together right? Did I wire everything up correctly? Is it powered on? Hey, it's moving. That's a very exciting moment and very satisfying. Once it's all moving, it's time to start assembling things into the larger robot. And these robots are great because they assemble really easily. They just kind of snap together, and there you go. You have a completed robot without any real difficulty. Another important thing to note here is how you see me in the bottom corner there. We did a lot of distant or remote collaboration where I could remote in through a Discord server, other visual technology, and help people build and communicate with the robots and be there virtually. That also is true with coding. So I could be there, and through the magic of screen share, I could see the code working on people's computers, and we could collaborate virtually to try to see, hey, even though I'm on the East Coast and you're on the West Coast, we can collaborate and troubleshoot and make things happen. And this went even further to playing the game itself. You set up a camera pointing at the game board, and you can be there. All you have to do is have access to the game server's web interface, and you can play the game remotely with people across the country in their environment and have a virtual camera that is pointed at it. So I just want to show the board and the game moving. You can see that's what the program looks like when it's fully put into a robot, and the robots will try their best to follow those programs. You can see them moving across the board. And these right here are our least expensive. They're $50 or so for these robots all together. They don't have any fancy navigation. They just use a gyroscope and dead reckoning to move. But as an entry point, we wanted to try to target the least expensive way to make it the most accessible to everyone out there. And so while their movement isn't perfect, you can see the orange robot in the top here is going to, as it moves, wander off course a little bit. You can see it's coming up a little bit. It's not going perfectly straight. And that's fine. Again, we haven't tuned these robots too much, and as a cheap $50 robot, it was a good start. But if you want to make a robot that has better navigation, that uses more complicated navigation techniques, there's no reason you couldn't build a more expensive, more complicated robots. But this is sort of just like our base level. We want to make it the most accessible to the most amount of people. So another nice thing about these robots is you can see their screens. And as we'll see in the next sort of section here, they have these wonderful LED screens. Right now they're showing the numbers which correspond to what player is controlling that robot. So player 1 or player 2. And you can do a lot of fun things with these robots. Not only can you make them expressive with different colors, you can also change the screens to make them more interactive. So as you'll see here, this robot in a moment is going to find itself being shot with a laser from the robot behind it. And it's going to change its screen to have a little surprise face for just a second. So even though these are very simple robots, there's still a lot of expressiveness and creativity you can implement. And they're just really happy and fun to work with. So of course, I want to give special thanks to all my collaborators there at the Bellingham Makerspace who helped put this all together and were there, my hands and eyes, remotely when I was not there physically. So I've talked a lot about this project. I've talked a lot about what we've done. But now I want to take a moment to talk about how this compares to other projects that exist out there that are similar. So what you can find often are family project kits. You can find these on Amazon. They're little cheap kits that you can take buy a little robot, have a little booklet with a bunch of activities you can do, and they're great, but I find that they're a little bit limiting. I'll talk a little bit about that in a second. You can also get sort of formal education kits. These are more complicated kits that you can often see and get in bulk to bring to a classroom for a robotics class, where you'll get a dozen or 2 dozen of them, get your students to build this robot and go through the workbook together. I'd also be remiss if I didn't give a shout out to a sister project that independently developed a very similar project to this. This was Super Robo Rally by Steve Hassenplug, who built this using Legos. And it's absolutely incredible. If you have a chance, just check it out. He built this entire thing using Lego robots with a very similar design idea, and it's really cool. But even so, I think RoboRuckus, this project, has a few advantages over any of these other ones. First off, it's a structured game. So unlike these first couple of options, which are just sort of open-ended kits, there is a game here. There is a structure, there's a scaffold that helps direct your purpose. You're not just building a robot because you're building a robot. You're building a robot with an intent to do something specific with it, to play this game with it, which gives you a bit more motivation, a bit more context for why you're doing this. Also, the RoboRally game, the board game itself, is really fun. And it's equally as fun with robots. So even when you're done building the robot, it's not just, oh, I built the robot, I've completed the booklet from Amazon, I'm done. It's, oh, now I can play this game. I can play this game as much as I want to. So there's intrinsic value there. It's also much more flexible. So you can find that some of these kits, once you build a robot and do its pre-designed ideas, there's not a lot more you can do with it. You've gone through the workbook and it's done. It's designed to do the stuff that the workbook tells it to do, and maybe not as much beyond that. This has a lot more flexibility in that way. It can also be integrated into curricula. So it also can do the same role as these classroom kits, but you can imagine having a situation where you take your students to say, hey, we're going to play this game at the end of the semester, and during the semester, we're going to build these robots. Each of you can design and build your own robot, and at the end of the semester, we're going to have a tournament where they're all going to play together on this board game with whatever design you get. I thought it could be a really fun and creative way to engage students. And most importantly, cost. As much as I love the Super RoboRally, Legos, as anyone knows who's ever tried to buy them, are not cheap. And so this thing has an entry point of only about $50 for the cheapest robot, which means that they can be very accessible. For maybe a few $100, $200, you can get a number of robots, 4 robots, and a Raspberry Pi or other game server, and have everything you need to play this game. So what have we done with this project already? Well, we've taken it to Medgar Evers College at the Science Expo, and you can see some students very interested and engaged there. We've also taken it to the Origins Game Fair in Columbus, Ohio, and this was a board game convention, but I would imagine it's pretty obvious that there is a pretty big overlap in the Venn diagram of people who are board game nerds and tech nerds or robot nerds. So there's a pretty good overlap there. And so this is a good way to reach those people and engage them in a project that they might not otherwise be interested in. We've taken it to the Bellingham Maker Fair, which will be held annually in October. So look for us there this October if you want to check it out in person. Or, of course, you can always come by the Bellingham Makerspace earlier to see it. We've also taken it to the New York World Maker Fair. I want to highlight something in this video here is the fact that the kids, look how the kids are really engaged, no matter how young they are, by this, because it's a fun game, it's bright colors, it draws them in, and they're really interested in the gameplay of it. And even up here, you can see kids were observing and watching it for hours while their parents played, and some of them even played with their parents. And because it is a game, it gets them involved, and it keeps their attention. And then, as I'll talk about later, you can start introducing new concepts and slowly increasing the complexity of the learning. So at the World Maker Fair, we also won the Editor's Choice Award 2 years in a row. So that was very gratifying. And we also had an article featured in Make Magazine. So we've had a little bit of success, but I still think there's a long way to go in terms of where this project could be. So how can we use this project as a teaching tool? So one of the most important things about this project, it is one project for progressing at all levels. So I mentioned earlier how kids start at a certain level and really seem to engage with this project, and that's just playing the game. And then once you want to go beyond playing the game, you can start introducing the idea of maybe building robots or maybe programming. And maybe as they get older, they can start saying, okay, I've played the game. Now I want to learn how the game works. And they can slowly increase to different levels of complexity as they progress in their education. And it's adaptable to their interests. What that means is, let's say, as they learn more, they want to learn about hardware. So building physical robots. Well, they can sit down and say, okay, I want to start building robots to fit this game. And the game has that scaffold in place to provide enough direction that they won't feel lost or overwhelmed with choices, but enough open-endedness to let them be creative and really explore. And if they want to learn about programming robots and robotics, they can do that too. So they can sit down and learn how to program robots and how to get them to talk to a game server, how to get them to move, how to improve movement, how to use hysteresis, or how to use different movement techniques and integrate different sensors through software. So there's a lot of flexibility there. But let's say they're not interested in any of that. Maybe they're interested in back-end web development. Well, they can work on the game server side of things and learn about how the back-end web development works and how to build a web application. Or if they're interested in UX and user experience design, they can work on the front end and design a new user interface and really improve the user interface because, as you saw, it's functional, but it's just not very pretty. So there's a lot of things that can be done to improve there. So this is really a scaffold for self-directed learning where you can see that this is a project and you can find the part of the project that interests you and dive in and go as far as you want in the complexity, as deep as you want into buying a robot kit all the way up to building your own circuit boards and designing your own PCBs and everything in between. It also ties in numerous other skills that are indirect to the game itself. For instance, I mentioned that we got involved in 3D printing and PCB design. And you'd also say mobile application design. So if someone wanted to make a mobile app for Android or iPhone that would integrate with this project for the interface or for controlling the robots, they could absolutely do that. And most importantly, these skills are transferable. So the skills you learn from this aren't just tied to, oh, I programmed these robots for this game. I don't have any other idea of how to use those skills. I can tell you from personal experience, I have managed to use the skills I've learned, the programming techniques and ideas in both my professional work, that is not directly related to computer science, and also in my hobby work. So these kind of skills can be used in any other areas. And also, to be clear, I'm not saying the RoboRuckus project is the only project that can be used this way. Any project can be used as a scaffold for teaching or a scaffold for self-directed learning. There's another different project that you've been talking about with your friends while drinking a few beers or whatever that you want to try. Like, hey, I'd be really cool if I could do this. That could be a really great project that could follow this same sort of model of learning that you could use to direct your learning towards the specific areas of your interest. So how can you get involved? Well, first, things that we need, as I mentioned, we can expand the game server. If you want to add new game elements, if you want to change our communication methods, add new ways to talk to robots, or port it to different platforms, that's one way to get involved. You can add or refine robots. If you want to add a new robot, if you want to design your own, if you have a new kit you think would be really cool, that's great. Or if you want to take some of the robots we already have and try to make their movement better, also great. This is a project for all skill levels. Again, I want to emphasize that. Even if you've never touched a robot or a piece of code in your life, this is something that you can find a place to get started. One of the things people say to me all the time is, I want to get into this, but I'm overwhelmed. I don't know where to start. Well, we're happy to provide you an entry point that'll get you started, give you some direction, and then from there you can sort of find the path that is best for you. But most important, if you want to get involved, it's all about having fun. So, some things I want to highlight. The Bellingham Makerspace is excellent. They'll be having a robotics make and take this summer with some of the robots kits we've highlighted here. Now, those robot kits at that make and take class will not be specifically made for this project, but you'll get those same robots. You'll get some experience programming them. And if you want to use them for this project, that's great. You can do that. And if not, you still have a really cool robot you can play around with. The best place to get involved is the TAG Discord. So you can find the Discord there. You can jump into the community hub, find us in the robotics channel. We'll be able to give you any details you want on this project, get you involved, get you up to speed on every part of it. And lastly, of course, you can find this project at GitHub. All the code's up there. And again, if you're something you're not sure about, you can't find, hit us on the Discord. We'll give you whatever information you want. So with that, thank you so much for your attention, and I look forward to taking your questions. If there are any. I don't believe, Garth had a great question here. You don't need to be local to participate at the TAG group. As you can see, I'm not a local person in Bellingham, Washington, and I can participate remotely. So pretty much from anywhere out there, you can come in and join us at the Discord and participate. So don't worry about borders or distance. So great question.
Yeah, that was an awesome presentation, Sam. I really do appreciate this. I'm looking forward to how much interactivity we have with the kids this summer. We've already had quite a bit of interest of people coming into the makerspace interested in this program and learning from you and the others on how to build their own robots. It's fun to see the gleam in the eyes of not just the kids, but the parents that are excited about,
Well, I think that's a key part that I really wanted to highlight here, and you're absolutely right, is the fun factor. Like, adults as much as kids love having fun. And so if you give them a project, it's like, hey, this is fun, it's going to get them excited about it. It's not just, hey, you're building a robot with no real purpose. Here's a really fun thing that you can do with these robots, and we're happy to help. So yeah, it's really great to see how excited people get about this. If you don't have any questions at the moment, and I'm so happy to take any more, I will be back at the Wonder Me space hanging out so that you can come and we can chit chat about some details if you have something that's a little bit more complicated you want to get into that isn't just a simple question.
But there's several people already convening there, I see, in the hallway track number 1. So yeah.
Well, I'm excited to go and speak with them. But yeah, so if there are any other questions, please let me know. And if not, we can wrap up here when everyone is satisfied. All right, well, I think that's a good place to start then, unless there's anything else. All right, well, again, thank you so much for your attention. I know that was, quite the long and rambling story, but again, I hope I can serve at least as an example that anyone can do this. And if you're interested in getting involved, we would just love to talk to you. So again, thank you so much. I look forward to speaking with you throughout the rest of the conference.